Signals are one of the most ubiquitous trackside accessories on any model railroad, perhaps second only to telephone poles. But unlike telephone poles, signals offer an opportunity to add lights and action to your model railroad. In addition, working signals add interest and variety to your operating sessions. Welcome back to my channel, and as always, thanks to my subscribers. Here are two examples of single-head signals. The signal on the left is a Type D signal equipped with three separate LEDs, one green, one yellow, and one red. The signal on the right is a Type SA searchlight signal with one lamp which can display green, yellow, or red. Since this particular searchlight signal uses a three-color LED with four leads, these two signals are electrically interchangeable. Most often, a three-color signal head is used to display one of just three aspects: green meaning clear, yellow meaning approach, and red meaning stop. If you're modeling a specific prototype, you should do some research to determine what aspects your prototype uses. If you're freelancing, you'll need to decide which aspects you'd like to model. Three-aspect control of a three-color signal is by far the simplest control scheme possible. Here is the circuit board I use for three-aspect signal control. The board provides contacts for a three-color signal head, a DC power supply, a toggle switch to control either common anode or common cathode signals, and a three-position switch to select the desired aspect. The production file for this board is available on my GitHub page. This board provides CTC control, that is, the aspect of the signal is controlled manually, in this case, by a switch. You can mount the switch on your fascia close to the signal, or you can mount the switch along with all other signal control switches on a dispatcher's control panel. Here are the parts you need to build the circuit board. First, this printed circuit board. I bought 10 of these boards for just over $7, including shipping. Second, a 2-pin screw header block for DC power. Third, a DP-DT switch to select common anode or common cathode wiring. Fourth, two 4-pin header blocks, one for the signal and one for the rotary switch connection. Finally, you'll need 3 resistors matched to the LEDs in the signal. Solder the components to the printed circuit board as shown here. Remember to use very tiny dabs of soldering flux. Flux is electrically conductive, so you'll need to use IPA to clean any excess flux off the board when you are finished to prevent shorts. When the board is finished, connect the signal to the signal header block, connect DC power to the power block, and connect the switch to the switch block. I use 4-conductor telephone wire to make this connection. Don't forget to set the DP-DT switch to the correct position, depending on the wiring of your signal. There are 2 advantages to this control method. First, it's inexpensive. Including a rotary switch, you'll spend less than $20 to control a signal. Most commercial controllers will cost $40 or more. Second, since the switch is a mechanical device, it remains in position when you power your layout down, and when you restore power, all signals will display the aspect from the previous operating session. Many, if not most, commercial signal controllers initialize to a default aspect, requiring you to reset the aspects of all your signals when you power up your layout. This method works beautifully as long as you only need 3 light effects: steady green, steady yellow, or steady red. But many railroads used many more aspects, some of which require more than one signal head. This chart showing aspects used by Canadian Rail is one such example. I would not recommend using all of these aspects on your model railroad. Your guest operators could never master all the operating rules. But in my case, the the Rio Grande used 4 aspects, which can be modeled using a single head. Those aspects shown here are clear, approach medium, approach, and stop. The approach medium aspect requires a flashing yellow light, and this requires more automation than our simple controller board can produce. This is where an Arduino becomes important. By adding an Arduino to our circuit board and modifying the board connection slightly, we can easily control 2 3-light signal heads using a single Arduino Nano. The Nano adds between $4 and $9 to the cost of the board, depending on which Nano clone you buy. Here is the circuit board I designed for my layout. The design file and the production file for this board are also available on my GitHub page. This board will control 1 or 2 3-light signal heads. It has 4 input connections, allowing selection of up to 4 aspects using a 4-position switch, or 6 aspects using a 3-position switch and an auxiliary switch machine contact, or up to 16 aspects by using up to 4 toggle switches to input the numeric value of the aspect. Here are the components you'll need to assemble this board. First, the printed circuit board. Second, 2 4-pin screw terminals, one for the signal and one for the selector switch. Third, a 2-pin power screw terminal. Fourth, an SPDT switch. Fifth, 3 or 6 resistors, one for every LED in your signal. Sixth, a 40-pin female header block. And finally, an Arduino Nano or clone. To assemble this board, solder all of the parts to the board as before, saving the header blocks for last. As you can see, the header block is too long. The Arduino Nano has 15 pins on each side, so you'll have to cut 2 15-pin pieces from the 40-pin block. Plug the Nano into the 15-pin header blocks and fit the assembly into the printed circuit board. This ensures that everything will align perfectly and allow the Nano to be removed and reinstalled later. Now solder the header block pins to the circuit board. You might be tempted to solder just those pins that require an electrical connection. Resist that temptation. The solder joints provide mechanical strength as well as electrical connectivity. If you do not solder all the pins, the header block might pull loose from the circuit board when you try to remove the Nano. Once the header blocks have been soldered in place, you can remove the Nano, for programming if you like, and reinstall it easily. You really need just 7 connections for a 6-light signal, a common, 2 green, 2 yellow, and 2 red connections. However, 7-pin screw terminals are hard to find, so I designed the circuit board to accept an 8-pin screw terminal. The 2 end connections are the grounds, and they are connected by the printed circuit. If you don't have any 8-pin screw terminals, you can use 2 4-pin terminals side by side, or even a 4-pin next to a 3-pin terminal. With the board complete, it's time to create the Arduino sketch to control the signals. Most of this sketch was created in my video C++ Classes Part 2, Class Hierarchies. See that video for a complete explanation of this code. For this sketch, I have added a rotary switch class. All this class does is monitor the position of the switch. When the switch position changes, the loop function retrieves the new position and updates the signal aspect to match the new switch position. Once the signal has been connected and power applied to the circuit board, the signal displays the selected aspects. First clear, then approach medium, then approach, and finally stop. I made this switch faceplate to mount on my fascia. I created the text and graphics in Inkscape. Then I printed the design on a sheet of self-adhesive label paper. I cut a square of 30 thousandths styrene sheet and applied the label to the styrene. I will drill a hole in the center for the switch shaft and mount the faceplate to the fascia with small screws. In order to demonstrate the power of this control system, I connected this 2-target signal to the control board. Notice that I used a 3-pin screw connector for the lower target, and I connected both common leads to the left-hand common terminal. Then I modified the Arduino sketch to allow this signal to display as many of the aspects defined by Canadian Rail as possible. There are 13 aspects that require 3 targets for correct display, so I could only model 11 aspects. Then I programmed the Arduino to cycle through those 11 aspects, 5 seconds per aspect. Obviously, the board must be modified to process the manual selection of the signal aspect. There are certainly 11 position rotary switches available, and the Arduino has 9 additional pins which can be used for input. But I suspect a more sophisticated aspect selection mechanism would be needed if you want to provide more than, say, 8 aspects. In the description below this video, you'll find links to many of the products and tools I've mentioned. I'd love to read your comments and to respond to your questions. If you want to see more videos of this type, be sure to subscribe and hit that like button. Thanks for watching, and I'll see you next time.